Hey guys, welcome to day 16 of the Arora AKT 30-day challenge. If you're watching this in the morning, afternoon, evening, or whenever you're doing so, hopefully you had a good day or having a good day. If you're binge watching and you've just watched the previous 15 all in a row and this is the 16th, then hopefully you're getting a good score in terms of the questions that we've been doing so far. This is a stats question. I remember stats myself. I hated it. I really hated revising for stats. Probably because I didn't understand it and I feared it, and I kind of put it off and put it off and put it off, and I walked into my AKT, to be honest, not in the best position. I know my stats 100 times more now because I've gone back into principles when I started to teach AKT stats. But at the time of the exam, yeah, it frustrated me, and I remember sitting there thinking, why am I learning all this stuff? Like, what's the benefit? What's the value? And of course, there are bits that I then went on to use later on, but it's just one of those things that, I mean, the reason the value is there, the reason putting the time in is of value to you right now is because there's 10% of marks up for grabs, and you really want to grab some of those, because actually if you get a basic grasp of the principles, then actually you can get a few easy marks in the exam. If you leave it all to chance, if you leave it all to cram, then you're less likely to take advantage. So this is a stats question then. I want to go silent 57 seconds. This one may not take you 57 seconds as with some stats questions, but we'll do it the same and consistent across the board as always. Have a think, jot down your answer, and we'll come back on the other side and go through some principles and some little techniques to make these kind of questions a little bit more straightforward. So 57 seconds, let's begin. There we go, guys. 57 seconds. Now, put a comment below if you had no idea about this, if you were completely guessing it, if it was, if you've not looked at labo plots before. Let me know in the comments, and hopefully after you have, if you've not done this before, hopefully you've picked up something that puts you in a better position for answering these questions going forward. So, several trials were carried out in different countries for a new drug to treat SLE. The results were plotted on a graph. So this is a labo plot, of course. Which of the below statements is incorrect? So which statement is incorrect or false? The answer is D. So well done if you got D, and we'll go through why in a second, but all the other statements are true. 4 studies failed to show more benefit from using the new drug. We'll talk about this in a second. The line of equality doesn't change based on the number of trials. I bet a lot of you guys put this one. Not because you perhaps didn't know what the line of equality means, but technique can get this one wrong. 60% of studies showed that the placebo was better than the new drug. That's true. And E, the smallest study in terms of patient numbers, showed a better outcome with placebo, which is true. So let's have a look at labo plots. So labo plots are basically an example of a scatter plot. They're just a fancier version of a scatter plot, and they're useful to look at. Has there been any difference in a trial with a drug versus a placebo, or drug versus a control? So usually you have positive response to a drug or an intervention on the side here, and positive response to a placebo on the bottom. That's the usual way around that you'll see it, and you'll have lots of circles. The circles represent individual trials all looking at the same thing. So here you can see there are 5 studies that looked at the new SLE drug versus placebo. 1, 2, 3, 4, 5. One study showed no difference between the drug and the placebo. That is this one. So this is the line of equality here. So any trial that sits bang on the middle of this line basically is saying that, look, that the circle is not leaning towards one side or the other. So therefore it's showing that in that trial, it was about 50-50 in terms of which patients did better. Was it with placebo or was it with the new drug? And therefore, it didn't really show any significant results of nature. So one study in this setup showed no difference between the drug and the placebo. 3 studies showed better outcomes with the placebo. So any circles that are in this segment, i.e. closer to the placebo line at the bottom, are telling you that in those studies, the placebo group actually had a better outcome than those who took the drug. So anything underneath this line means that the placebo is better, and therefore one study showed a better outcome with the new drug. So this is the one study that's clearly, or completely, I should say, in this segment. So therefore, in this study, the patients who took the new drug fared better than the patients who took the placebo. So overall, if you look at this, it's not a great advertisement for the new drug, because the majority of patients either show equal effectiveness with the placebo or worse than the placebo itself. So we'll come back to those points and put them into the answer in a second. And then a quick review of systematic review versus meta-analysis. Now, say, for example, you have a lot of trials, randomized controlled trials, for example, looking at a certain drug done by various different people or institutions, and you naturally want to look at results on a bigger scale. So you have lots of different results of trials that might be really good or really bad, but you want to put them all together to give you more power in terms of research. So when you look at that research pyramid, if you remember, if you've seen our online stats course, you know that pyramid that we talk about, right at the top is meta-analysis and just underneath is systematic review. And they are both collections of lots of trials that you'll find further down the pyramid, but just in number. So they're stronger because you have more numbers involved. So the main difference is how you analyze the results, though. So a systematic review is a qualitative analysis. So there's no stats involved. So you get a whole bunch of trials and you write basically a descriptive analysis of the findings or the combined findings, and therefore there's no numbers involved. It's a qualitative, not a quantitative analysis. The meta-analysis is the tip, so the highest level of research, because A, you've got lots of trials put together, but B, you've got a statistical analysis, so a quantitative analysis, and because you've got numbers involved, that's why that's highest on the pyramid. Now, this therefore is a graphical representation of a meta-analysis, because you're using numbers. It's not just and those numbers have been put onto a graph, so a graphical form, and it's not just a descriptive analysis. Therefore, the answer to this is D. The incorrect or false statement is D, because this says this is a graphical representation of a systematic review, and that's not true. It's a graphical representation of a meta-analysis, and that's why that is the answer to this question. All of the other statements are true. So 4 studies failed to show more benefit from using the new drug. So all of these 4 studies didn't really show a benefit in using the drug. So some of you guys might have thought the answer here was 3 studies, but actually this one as well didn't show that the new drug benefited. Therefore 4 in total. So that's a true statement. B, the line of equality doesn't change based on the number of trials. So that's true. The line of equality remains the same, obviously, regardless. And it doesn't change whether you've got 3 trials or 300 trials. So you might know that the equality of the line of equality doesn't change, but because it's looking for a false statement and there's a negative in here as well, that can play with your mind sometimes, and that's where technique can take over. But that is a true statement. It doesn't. C, 60% of studies show that the placebo is better than the new drug. So that's these 3 here. So 3 out of 5, of course, is 60%. So this is different to A, where it's saying that 4 studies or 80% show there's no more benefit when using the new drug. This is clearly saying which ones show that placebo is better. So this one doesn't really show that, and that's why C is true, 60%. And then E, the smallest study in terms of patient number, showed a better outcome with placebo. So the size of the circle represents the size of the study. So the larger the number, the circle, the larger the number of patients. So the smallest study, the smallest circle, showed a better outcome with placebo, which is true because it's in this area of the graph itself. So hopefully you can see why D is the answer to this question. So 2 main takeouts from this question. Number 1, what's a Labe plot and what does it mean? How do you interpret it? And then secondly, what's the difference between a meta-analysis and a systematic review? Now we have more teaching on both these areas, but also all of these areas as well, including all the other graphs that you need to know for AKT, the bare principles of the basic graph, so that you can work out other ones that appear really random when you first look at them in exams such as this, but also all the other bits and bobs, the equations, the calculations, the evidence, the research that you need to know for AKT in our Super Stats online course. So the whole point of this is that you can use it at your own convenience. So it's an online course that you can pause, watch, rewind, go back to multiple times. It's split up into 5 different chapters based on the 5 core areas of stats, and one of them is graphs. A 1, 3, 6, or 12-month subscription. So plenty of time to make use of this if you still haven't started stats yet and you're kind of not sure where to start. So sometimes people do lots of questions, but they still don't feel confident. But this hopefully will take you through all the basics that you need to get right so that you can start to work out and become more confident with questions. So head to the website at auroramedicaleducation.co. You click the link somewhere down or up, depending on whether you're watching this on YouTube, Twitter, Facebook, Instagram, or LinkedIn. Use the coupon AuroraVideo10 for 10% discount. That's off the stats course, also the admin course, also the clinical course, or the bundles as well. And the stats course comes in a bundle with admin if you're just looking for stats. And admin, hopefully you're going to find out some value. Watch the free sample of the course on the website before you make the purchase to see if it's something that will work for you. I'm sure it will. Hopefully this has been some value. If you do fear stats, please do not worry. You've just got to get a grip of some basic principles, and then your confidence will start to soar, and hopefully you'll get an easy 8 to 10% when it comes to AKT, because as you guys know, every single mark counts. And please don't be one of those people who kind of think, well, I'll not really focus on stats and admin because I'll just nail my clinical, because the clinical stuff, as you've seen from the previous videos, can get you both from a knowledge point of view but also technique point of view as well. Take care, guys. See you tomorrow for day 17. #CampusWillPass. #I went with Arora. See you soon.